in quarters. All right, let's look at number 3. On number 3, are we using product or quotient rule? Is it product? Let me write this out first. So we have sine of x over 2 cosine of x. And just as a reminder on the quotient rule, it's similar to the product rule, but the sign in between is plus or minus. What is it? It's a minus. So our derivative, I should write f of x. So our derivative, f prime of x, and as a reminder, always do the bottom one first. What do I do with everything on the bottom? Square it. So on the top, we know it is separated by a minus sign, so go ahead and put a minus sign. So the rule was we derive which one? The top. What's a derivative of sine? Cosine. So I'm going to put that in parentheses. You don't have to if you're going to put times right after it. And do I mess with the bottom one? Not at the moment. And then minus, we keep the first one. And when I derive the next one, we know cosine derivative is what kind of sign? Negative. So I need to put negative in front of the 2. And done. Wow. Okay, now let's go on to number 6. So on number 6, we have y is equal to x times. I'm going to put that in parentheses, even though it's not on there. So which rule are we using for this one? The product. The product rule says derive the first one. What is a derivative of 1x? 1. And we keep the second one. And it is separated by a plus or minus? Plus. We keep the first one. What is a derivative of secant? It starts with secant. Tangent. Make sure you know these. It's either you know it or you don't. And then let's go on to number 13. Okay, 13, it looks like we're doing implicit. So let me write that out. So we have y cubed minus x squared is equal to 7. So are y'all good for me to move this on up? Okay, bringing it up. And let's go ahead and take the derivative with respect to x. Okay, what is the derivative of y cubed? 3y squared, very well. Because we're deriving something without the x, what do I need at the end? dy over dx, very well. And then derivative of negative x squared is how many? Just minus 2x. That's already in terms of x. I don't need any more. And the derivative of any constant is what number? 0. And I need to make this one by itself. So what I'm going to do is move the 2x over and divide it by this guy. So we have dy over dx is equal to 2x over 3y squared.
The volume formula for a fan is V equals 1/3 pi r squared. Find the rate of change of the volume if dr over dt equals 4 inches per minute. H equals 3r and r equals 2.
Okay, let's start by writing that acronym. What was that acronym called? FWIGI. Now keep in mind, any part that is relevant is correct. I'm going to give you partial credit, so make sure you write everything out. Because if you don't write it, I can't see it, I can't give you partial credit. So what F stands for find. What are we finding? The rate of change of the volume. So we have dV over dt. When is all the given pieces? What pieces is given after when? Well, this one didn't have when, right? What given pieces are there? The radius is how many? 6 inches. And then it says our height is 3 times the r. Ooh. So let's just write that expression on the side for now, and we might use it at the beginning and or maybe at the end. So let's write out our height is 3 times the r. So 3 times bigger than the radius. What is a given rate? Did they give us a given rate? dr over dt, correct? 4 inches per minute. And what shape are we looking at? A cone. And our cone formula is given, still write it out. 1/3 pi r squared times the h. So here's what's going to happen if I choose to not do anything about converting anything. How many variables do I see here? 2. So I would have to use product rule. To avoid using the product rule, if I plug in 3r in place of this h, everything will be in terms of the radius. And when I simplify them, I don't have to use product rule. So let's go ahead and plug it in. Our volume is 1/3 pi r squared, and our h is equal to 3r. And let's see what happens when I further simplify. What's going to happen to the 3 and the 1/3? Cancel. So I have pi r. How many r's do I have now? 3 of them, cubed. Very well. So let's go ahead and write that formula out on the side so we can do our derivative. For all the word problems, we are deriving with respect to what letter? T, because it's a time. What is the derivative of 1v? Just 1? But we have to add dv over dt. So if you want to write the 1 in front, go for it. But I understand that it is understood 1. So I'm going to just kind of ignore it. Okay, what about the derivative of pi r cubed? 3 pi r squared, and we need to go ahead and put dr over dt. So what's nice about this one, we have dv over dt is what we are looking for. Isn't that already by itself? Yeah? So I can go ahead and plug in 3, the pi. How many is the radius given? 6. Squared. What about the rate of the radius? 4. Because the rate of the radius is 4. And let's go ahead and further simplify. And if I want to leave this in terms of pi, 36 times 4 times 3. Any good mental mathers here? 442. Almost. 432. In the word problem, it's going to be a calculator portion. So if you're like, well, I can't do that, it's okay. And I should write out dv over dt is equal to that number. All right, that was number 17. Let's go on to number 19. Oh, is everyone good with the 17? Good? Okay, Cassidy on number 19, let's read.
The area of a circle is increasing at a rate of 12 pi squared per hour. How fast is moving the radius is 3.
Okay, I'm going to move this paper since it's a big mess on number 17. So here's number 19. What's the acronym that we should write out? FUIGI. So we have FUIGI. And look at your word problem and let's kind of figure out what we are looking for. We are looking for the change in what? Change in the radius. What pieces do I know? 3 feet. And then is a given rate given to us on this one? It was a rate of the change in what? So that's the area when you have square inches, dA over dt. And that was 12 pi inches squared per hour. And our equation on this one, what shape are we looking at here? Circle. What is the area of a circle? Pi r squared. So let's write that equation on the top. So we have dA, that's a d, okay, I meant A is equal to pi r squared. Get rid of that one. Now find the derivative with respect to t. I guess I could have left that d alone. So let's kind of figure out what's happening here. Our unit must be consistent. Look at the unit of the rate that is given. Is it in feet or inches? So all of our units must be consistent to the rate. So how many inches are in 3 feet? 36. So I'm going to say that one more time. If your dimensions are not exactly same as the rate, you have to make it common. All right? What is the derivative of 1a? 1. So let's write out dA over dt. What is the derivative of pi r squared? 2 pi r, and we need to add dr over dt. And it looks like we have all the given except dr over dt, since that is our final goal. So let's plug them in. We have 12 pi is equal to 2 pi times the radius of 36. Then I have dr over dt. Could I cross something out on the left and the right that is identical before we simplify? The pi. And then what I can do is dr over dt is equal to 12 divided by 2 times 36. If you want to say 12 divided by 72, that's okay. How many is 12 divided by 72 that is simplified? 1 over 6, very well. So 1 over 6, it's the radius. Radius not inches squared, it's just inches, per hour. Get rid of that. And done. If on the test I'm asking you for a decimal, you can just type that in. If on the test, if I also ask you for a decimal on this one, you can multiply out the pi. Okay? But this is perfectly fine. Are we good on this one?